biological. Of course, you have the non-biological factors or the non-biological forces. Okay, include, for example, as already you know, like, okay, include rain, wind, okay, and what do you call temperature changes, okay, especially to mention this point here, especially like freezing and thawing. Freeze and thaw cycles. Now, basically, of course, some of the biological influences. Okay, include, okay, like for example, the rock cracking forces, the rock cracking, basically that occur, of course, what you call by the plant roots, okay, forces that can be excreted by plant root. This is what you call definition of what you call of weathering. Now, erosion, okay, this is basically refers to the physical removal of rocks and soil, okay, through the action through the action or actions of flowing water, ice, wind, and gravity. Okay, and gravity. And also to mention that erosion is a pervasive as I mentioned, basically erosion is a pervasive geological processes processes occurring at various rate in all environment. at various rates in all environments. Okay. Now, of course, we're going to mention, of course, over extremely long periods of time, over extremely long periods of time, as already know that weathering and erosion tend to create basically a relatively flat and homogeneous landscape. A relatively, put it down here, flat and homogeneous landscape known as peneplain. I'm going to show it to you. Give me a second here. Known as peneplain. Something like that. You see this one here? This is known as peneplain, okay? As you can see that as a result of erosion and weathering at the same time, but of course this occurs over a long period of time. The habitat, as you can see here, what you call homogeneous, what you call and flat. So this is known as peneplain, and it depends on many factors also to mention this point here. And also you can see this one here basically occurring in some area in Central Asia, okay, like this one here, right? Something like that, or like this one here, okay? So basically that's known as a peneplain, okay? Then we're going to talk about a little bit about what you call about the hydrosphere. Okay. Of course, as already you know, as a matter of fact, in this case, basically that of the ocean. So now, the Earth's hydrosphere, or Earth's hydrosphere, okay, is the portion of the planet that contain, of course, water. That contains water, okay, including, of course, the oceans, including the oceans. Okay, and also the water which is in the land surface. Okay. Okay, and also on the underground water. Okay. Now, usually we'll talk about, for example, called the hydrologic or water cycle, to mention this point here, the hydrologic or water cycle basically refers to, okay, the rate to the rates of movement or fluxes of water, okay, among these various reservoirs. Reservoirs, which basically sometimes we call these reservoirs basically as a compartments. Reservoirs, or we call it compartments. Okay. And now to mention, of course, that each of these compartments, of course, it has what you call the input and output fluxes. To mention this point here, that each compartment of the hydrological cycle okay, has input and output. And output fluxes. Okay. And of course, and the sum of all that, which we call the cycle, and just to mention one, okay, and the sum, okay, of all of these comprises the cycle, and the sum of all these comprises the cycle. Now, basically, just to mention here, as a matter of fact, of course, in this compartment, we have about 4, and I try to distinguish this one here. I'm to mention now. We can distinguish 4 major compartments. Okay. Okay. 4 major compartments of the hydrological cycle. Okay. Now, basically, these compartments we mentioned here, of course, that basically we have, just give me a second here. Okay. The ocean, and also we have the surface water, and the groundwater, and also the atmospheric moisture. Okay. Then we just will touch a little bit on each of these one here. Okay. Of course, in the case, the oceans, okay, are the largest hydrological compartment, as already know, are the largest okay hydrological uh, compartment, and as you know, basically accounting for about okay, about 97.4% of all water on the planet, accounting for about okay 97.4% of all water on the planet.
Excuse me, sir. Could you move the
Yeah,
page
just
over
give
a
me a
little
second.
bit? We
Did you
can't see
finish on
that.
this one? Did you finish on this one?
Yes.
Okay. Is it okay
Thank you.
now?
Yeah.
Okay, thank you. All right, of all water on the planet. Now a little bit about what you call the surface water. Okay, which occur on Earth's land mass. Land mass. Okay, and account for about 2.3%. Percent of course, of the global water. Okay, 2.3% of global water. And simply to mention, this is got now most of this basically is tied up in what you call in ice. To mention, virtually all surface water virtually all surface water is tied up okay in glaciers okay, in glaciers, and mostly, of course, in Antarctica lake. Lakes, ponds, okay, uh, rivers, okay, streams, okay, and other surface body. This is surface and other surface bodies, okay. And all that basically is not that much comparing, of course, to the oil plant. Is all represent about 0.002%. And to mention to you that rivers, streams, and other surface bodies, okay, containing liquid and other surface bodies containing liquid, okay, water. This is all basically amount to about, okay, to only 0.002%, of course, of the global water. Okay. Now they got a little bit about what they call to the groundwater, which can account for about 0.32% or 0.32 or 32%. Okay. Now to mention this groundwater account for about, okay, 0.32% of the earth of Earth's waters. Water. Just to mention a few points here. And to mention the other point, of course, that groundwater sometimes could be relatively shallow, but sometimes it could be very deep and sometimes even unapproachable. And to mention this point here. Now, groundwater can occur in relatively okay. Shallow soil horizon. Shallow soil horizons, okay, where it is accessible okay, for uptake okay, by plants. Okay. Or, of course, or it can drain laterally. Is that what? Or it can, okay, drain laterally okay, into the surface or into surface water, into surface waters, such as lakes and streams. Okay. Of course, deeper groundwater is inaccessible, as I mentioned to you. Now, deeper, okay, deeper uh, groundwater is inaccessible, okay, for these purposes. Okay, and which is and basically and for what is known as, sorry about that, okay, and for, okay, known as the artesian reservoirs, and form, okay, reservoirs, okay, artesian reservoirs in spaces, okay, within porous, okay, of fractured bedrock. Okay, so basically, as you mentioned here, that basically the deeper groundwater, which is inaccessible for these purposes, and for what is known as the artesian reservoirs in spaces within porous or fractured bedrock. So this is basically, we talk a little bit about the groundwater. Now we're going to talk about basically the atmospheric moisture. Okay. And basically, this one basically accounts, okay, for only about, okay, 0.001%. Okay, 1% of Earth's water. Of Earth. Okay. Now, just to mention, of course, as you know, basically can occur, the atmospheric water can occur basically as a vapor, but also can occur sometimes as ice crystals, to mention this point here. Atmospheric water, okay, occur as a gas vapor, sorry, a gas vapor, or solid. And I mean by solid here basically as what you call ice crystals. As ice crystal, And basically all of that, they are very variable to mention this point, and all of which are highly variable. Okay, over space and time. And now simply to mention, of course, we have the cloud, is to mention this point here. Now, cloud are considered dense aggregation of liquid or solid water. Okay, liquid or solid water and the atmosphere. In the atmosphere. Well, simply, of course, we have the other one, which is known as gaseous water, which is basically this is invisible. And to make sure this point here, while gaseous water okay, is invisible. Okay. Okay. Now to mention, of course, there are basically the major, which is already known now. To mention this point here, the more important fluxes okay. Of course, among the compartment of the hydrological cycle, to mention here, the more important fluxes among the compartments of the hydrological cycle okay. To mention basically these are the factor R. One of them basically will be known as evaporation. Okay. Of course, this one also including basically, of course, transpiration or evaporation from the surface of the plant, including, sorry, okay, including a transpiration and evapotranspiration. Evapotranspiration. Okay. Then, of course, the other one, basically, we have the precipitation. And also the third one, basically we have, as a matter of fact, the surface flow. Called surface flows. Okay. I'm going to talk about each one a little bit of this one here to show its effect here. Now, to start with a little bit of evaporation. Okay, and to mention this regard, basically, which is globally about 86%. Okay, globally, about 86% of evaporation, as already you know, okay, is from the oceans. Okay, is from the oceans. And of course, and the rest, as a matter of fact, is from terrestrial surfaces. And the rest, here, okay, is from terrestrial surfaces, okay, such as bodies of surface water. Okay, I'm going to continue here. Such as surfaces, as I mentioned here. Okay. Okay, such as bodies, okay, of surface water, okay, from moist soils. Okay, and rocks, okay, and also and from vegetation. Did you finish on this one here? Okay, let's put that. And from vegetation. Now, as already I mentioned to you, basically, as you know, that transpiration, when you use the word transpiration, okay, consider is basically is specifically okay, specifically basically the evaporation okay, of course from the plant, okay, from plants. Okay. Well, of course, why when you use the terminology evapotranspiration, to mention this point here, while I'm going to continue here, evapotranspiration okay, refers, okay, to all sources, okay, to all sources of evaporation from a landscape. Okay. Now, basically, we talk a little bit about precipitation, but there's only one terminology I'm going to use. I don't know if you know about it. Now, precipitation okay. So basically, as already we know that most of the global evaporation, most of global evaporation, put it down here, okay, is from the ocean. Okay. And basically, of course, and much, okay, of which precipitate okay, back to them. Okay. Now, the other point I want to mention to you here that precipitation volume can be especially large. Put here that precipitation volume, okay, can be especially large in mountainous area. Mountainous areas, and basically this is known as, we call it the orographic precipitation, a phenomenon okay, a phenomenon known as okay, orographic known as orographic precipitation. Okay. Now, the other terminology we use basically that surface flow, okay, which is simply involve water, okay, that is transported okay, in streams and rivers. Okay, in streams. And rivers. Okay. Okay. Basically, this is basically in contrast. Okay, in contrast, lakes and ponds. Okay, which is known as are relatively okay. Static storage reservoir. Consider these are the lakes and ponds. Okay, are considered what you call are relatively static storage reservoir. Okay. Now, simply, of course, as already you know, basically that surface flow usually according to what you call in response to the gravity, to mention this point here, surface flow, okay, a move in response, okay, to gravitational water. Sorry, gravitational gradient, to gravitational, okay, leave to the gravitational, okay, gradients. Okay. Simply to mention, of course, associated with altitude. Okay. Now, the other point mentioned, of course, most of the water basically from streams and other what you call surface flow, usually most of the time will end up basically in the ocean in one way or another. And to mention this point, most surface flow, okay, carry, okay, most surface flow ultimately, okay, carry water to the oceans. Okay, to the oceans. And basically, by this way, they try to equalize what you call the evaporation occurring from the surface of the ocean, and to mention to the oceans, and to mention, and thereby balancing. Okay, and thereby balancing the net import. The net import of moisture, okay, evaporated, okay, from the oceans. Okay. And now just a few words basically with regard basically to the groundwater here. Now to mention about the groundwater drainage. Involves simply to mention the infiltration of water okay, involve the infiltration of water into the ground. Okay. By the way, of course, I received some of your titles. I didn't receive all of that. And hopefully, basically, I think I noticed somewhere they have a very clear picture, some they try. But anyway, I figured out maybe we next what you call meeting, all right, maybe by this Friday, okay, and I will send you an email with that and to see your response. At least we'll discuss it and we'll try basically to what you call to say to polish these ideas. Of course, we talk about it and see how they're going to deal with it. Okay, so we'll talk. But at least those students who didn't send me yet their topics of in which they want to work out, if they can do so, okay, or at least if they didn't. If they have the idea, so basically when we meet next time on Friday, at least they will discuss it. So basically, what you call, so that can be at least crystallized in this way, in their way to work on it. And now to mention, of course, groundwater drainage involve the infiltration of water into the ground. Okay. Now to mention this point that shallow groundwater shallow groundwater can drain laterally. Can drain laterally, and of course, eventually, okay, draining, okay, into the surface water. Into the surface water. And also to mention the other point, of course, some of the groundwater can also be taken by the root plant. And to mention also this, that it can also be taken okay, up by plant root. Okay. Of course, as I already mentioned, basically with regard to that, the deeper groundwater, or we call it the artesian reservoir, that is basically is not available, okay? But sometimes it could be also, it's very, very large. And to mention this point here, deep groundwater, Okay, meaning that deep groundwater is not available to plant also. Okay. To plants, and of course, and accumulate. Okay, and accumulate in underground called an underground artesian reservoirs. Okay, which can be very large. Okay. Now, finally, of course, to mention this regard here, okay, this point here about that, of course, this cycle of hydrocycle is very important to mention this final word in this hydrocycle cycle, the hydrological cycle, okay. Okay. Is extremely important. Okay, and is required. Okay, by natural ecosystem to function, and is required by natural ecosystem okay, and is required by natural ecosystem basically to function. Okay. Now, basically, after we finish this part here, we have to talk a little bit more detail about the atmosphere. I'm going to leave this one here, actually. Okay. Then we're going to talk about the atmosphere. Okay. I just want to make sure about this one here. Yeah. Yeah, basically, these are the points we're going to talk about the atmosphere, because as you know, the atmosphere, it has basically the stratosphere, the troposphere, and all this. So we're going to talk about each one of these a little bit here. Okay. Now, the atmosphere, okay. Now, the Earth atmosphere, as already we mentioned earlier, it is basically an envelope of gases. Okay, Earth atmosphere. Okay. is envelope of gases that surrounds that surround the planet and is held in a place and is held in a place, as a matter of fact, by the attractive forces of gravity. Of gravity. Okay. As already showed you, basically the atmosphere, of course, consists of 4 layers. Okay, so if you finish from this one, I just put it back here, I guess, so that we can continue here. Okay, now the atmosphere, as already mentioned to you, consists of 4 layers. Of 4 layers. And basically, these, of course, they have boundaries, but most of the time, these boundaries really varies over time and space. And to make this point here, 4 layers, and the boundaries of which vary over time and space. And now I'm going to talk first about what you call the first layer, which is, as you can see here, which is known as the troposphere, and to see the extent of each one. Now, the troposphere. But basically, we're going to make it this one here contains 85 to 90% of the atmosphere. Contains about 85 to 90% of the atmosphere. Or in other words, from the atmospheric mass. And basically extends from the surface, means the surface of the Earth or planet, from the surface to about 8 to 20 kilometers and usually that's why basically it is thinner at high latitude and of course and thicker at the equatorial latitudes. And to to you here, okay? And being thinner, okay, at high latitudes, and thicker, okay, at equatorial latitudes. Or equatorial latitudes, okay. Plus also, as a matter of fact, also the thickness of it also varies as a matter of fact with the season. And to make this point here, okay, as well as varying seasonally. Okay. Now, to make it the other point in this regard, basically, of course, as already we know that air temperature, okay, as you know that air temperature typically decreases okay, with increasing altitude. With increasing altitude, okay, within the troposphere. Okay, within the troposphere, and convective air currents or winds, okay, or winds, okay, are common. And basically, sometimes that's what we call, sometimes we call the troposphere basically as the weather layer because of that. And to mention to you here, okay? Okay, current here. Winds are common, okay? And consequently, the troposphere also is sometimes called okay, the weather layer. Okay. They're now going to move to this layer here, which is known as the stratosphere. Okay, we talk about this one here now, the stratosphere. Okay. Now, in fact, basically, the stratosphere basically extends, okay, from the troposphere to as high as 50 kilometer. Okay. $50 kilometer, and of course, depending on the season, can say that depending on the season, as a matter of fact, and latitudes, okay, within the stratosphere, within the stratosphere, okay, and there are, okay, mention, and there are, of course, a few basically convective air current. Called convective air currents. Okay. Basically, just now, I think, yeah. I think I will stop my lecture here. Next lecture will start with you what you call the mesosphere. Or the mesosphere. Okay. And I'll continue with that with the next lecture. Did you follow that okay, please? Or do you need any explaining or anything else? Please let me know.
It's all good. Thank you.
Okay. As I said, please, those students who didn't finish it to have an idea about their topics, okay? Or anybody here, if nobody has any idea, just let me know. We'll maybe discuss it and develop an idea. Okay, just let me know. Okay? Well, anyway, have a good day, and we'll talk to you on Friday, I guess. Any question, please? No, seems.
What's the word after few?
And a few convective
Thank
air
you.
currents. Did you follow that?
Yep, thanks.
You're welcome. Okay, then I'm going to end the what you call the Zoom now, and have a good day.
Thank you.
You're welcome. Bye.